Hi, ladies and gentlemen. This is Mr. Green. If you can tell by the announcements in the course today, I am probably teaching and giving a tax test, or a STAR test. So I am not available for Class Connect. I am sorry. That's why I'm making this recording. Now, I hope you all noticed that we had a slight change in order here. We're not doing homework 1 in chapter 8. We started with homework 5 in chapter 8. The reason for that is we have to know how to simplify radicals before we can do some of the things that are at the beginning of the chapter. So we're going to do simplifying radicals first, and then we'll get into into the first part of the unit. Okay? So that's when we're doing homework 5 and homework 6 before we're doing homework 1 and 2. Don't worry about it. It will make sense before we get all to the end of this process, okay? I want to keep bringing up this Pascal's triangle. I keep bringing up this Pascal's triangle because there's just so many patterns that we see in this thing that, it's just so interesting. You see these ones going down here. They're always ones. And you see the counting numbers going down here. They're always just 1 through 3, 4, 5, 6, 7, 8. And then you see triangular numbers. Well, triangular numbers are just numbers that 1, 3, 6, 10, 15, 21. It kind of goes like that. It's so interesting that you can see these patterns if you want to look at them. This is what the triangular numbers look like. You can see a triangles here: 1, 3, 6, 10, 15, 21. They make triangles if you stack them up that way. Okay? And we'll point out more as we go along, but this Pascal's triangle just has so many things that are so interesting in it that it really makes it a cool thing to be looking at. You know, Pascal, he was this guy who was born in 1623, lived until 1662. Long time ago. Yeah, just about the same time as Mr. Green was born. Yeah. He wrote a treatise, The Arithmetical Triangle, describing it, but Pascal was not the first to draw out this triangle this way. The triangle, or to notice its amazing little sequences that we see here, okay? He wasn't the first, but he's the one that gets credit for it, okay? We'll look at this triangle more as we go through the course, okay? So, what we're talking about today, what? Square trees? Anyone ever seen a square tree like that? Or a square tree like that? Or a square tomato? Or how about a square watermelon? You know what all these have in common? Square roots. Okay, long way for a bad joke. Square roots come from square trees. No, they don't. Square roots come from solving quadratic equations. Okay? Let's look at some square roots. I'm sure you've heard the term before. A square root is nothing more than when I multiply two numbers together, I get a value, and we're going backwards. It's like subtraction is backwards of addition, and division is backwards of multiplication. If I have two numbers that are multiplied together, or a number that's multiplied times itself, it's called a square. So how do I find that number if I know the square? Well, 81 is a perfect square. Why? Because 9 times 9 makes 81. 36 is a perfect square because 6 times 6 is 36. 4 is a perfect square. 2 times 2 gives me 4. 5 times 5 gives me 5. 3 times 3 gives me 9. 4 times 4 gives me 16. 7 times 7 gives me 49. And 1 times 1 gives me 1. But you know what? There's a whole other set of numbers that do these same things. Negative 9 times negative 9 gives me 81. Negative 6 times negative 6 gives me 36. Negative 2 times negative 2 gives me negative 2. I can put a plus or minus in front of every one of these because it could either be the positive number or the negative number that would be the square root of that value. Okay? It could be either one of them. So you always have to remember there could be a negative one there too. Okay, what about imperfect squares? This is not as fun, I can tell you. Because 18, you know what? 18 is 9 times 2, isn't it? And 9's a perfect square. I wonder if that's what we're going to be dealing with. And 66, well, that's 33 times 2. That didn't help me any. 27 is 3 times 9. There's another perfect square in that one. 40 is 4 times 10. There's a perfect square in that one. Do you see how I'm getting these perfect squares in there sometimes? And sometimes I'm not? 8 times 3, that's not a perfect square. 4 times 6, that's 24. So sometimes there's perfect squares inside of there. We can kind of estimate them. I know that 18 is between 16 and 25. So it's between 4 and 5, isn't it? It's not quite, it's more than 4 and it's less than 5. It's somewhere in between there, isn't it? And 40, that's more than 36 and less than 49. So that's between 6 and 7. See how I'm kind of narrowing it down a little bit? 27 is between 16 and or between 25 and 36, so it's between 5 and 6. You can kind of narrow them down a little bit to see what they're going to be like, but not necessarily get the exact number, can you? Well, Mr. Calculator can help you with those. I've seen people who I've taught in the past who've looked at me and said, "I don't know how to take a square root on a calculator." Well, I want to make certain you all know how to do it. So you can see I'm starting my calculator up here. And I'm going to bring it over here to the screen so we can all see it. There it is right there. Okay. And I'm going to clear it out because we don't want to be dealing with this stuff here. Trust me. Logarithms, not yet. So that first one up there, square root of 162. I'm going to push the second and the squared button here. When I push second and squared, it gives me a square root symbol. And I can just key in 162 and hit enter. And it tells me it's 12 something, 12.7279. Well, it's just 12 something. How about one of these that I estimated it here? How about 40? Let's take the second square root of 40. And what do we get? 6.32. And it's between 6 and 7. That worked pretty good, didn't it? How about square root of 27? Second square root of 27. And hit enter. And that's between 5 and 6. Woohoo! That's working pretty good. So estimating it might just mean a matter of finding out what values are on both sides of it and trying to get close to it. Okay, we can do that. I can handle that. But how do we simplify a radical? To simplify a radical, what we have to do is we have to see how many of those squares we can get out of that square root. So 125. I want to try this one. 125. I know that the square root of 125, I know that there's 5 times 25. That's what 125 is. So I'm taking the square root of that whole thing. You know what? I can break that up. I can take the square root of 5 times the square root of 25. Well, the square root of 25 is 5 plus or minus 5. And so I could say this is equal to 5 times the square root of 5 plus or minus. That worked good. You know what? 72. I've got 7 times the square root of 72. Well, 72 is 2 times 36. I got a 7 that's still out here, don't I? And I got the square root. I'm going to break it up into its individual parts. 7 times the square root of 2 times the square root of 36. The square root of 36, that's 6. 6 times 7, that's 6 times 7 times the square root of 2. Oh, you know what? That's going to be 42 square roots of 2. And it's going to be plus or minus. Woohoo! Down here, we've got 5 square roots of 10 times 3 square roots of 8. You know what? 5 times 3, that's 15. I knew that. Square root of 10 times 8. I put it back together, didn't I? Well, that's 80. So that's 15 times the square root of 80. 80, wait a second. There's a 16 in there. I know there is. I'm going to divide 80 by 16. 80 divided by 16 is 5. So this is actually 15 square root of 5 square root of 16. Well, 16 is 4, so 4 times 15 is 60 square roots of 5, and it's a plus or minus. Do you see what I'm doing to simplify these radicals? I'm breaking them down by their factors, and then once I get their factors down, I'm combining them back together. I'm looking for perfect squares, and I'm taking the perfect squares out of underneath the radical, solving them, and it simplifies the radical. That's what it's called, simplification of the radical. Okay, this one says find the area of a triangle in simplest form. Area, we know that formula. It's 1/2 base times height divided by 2. Well, my height is 15 and my base is 20. So I'm going to say area equals the square root of 15 times the square root of 20 divided by 2. Well, let's see here. 15 times 20, that's 300. So that's the square root of 300 divided by 2. Is there any perfect square that I could pull out of 300? You know, anytime I see things ending in 0, 0 or 100 like that, I know I can take 100 out of it. This is equal to the square root of 3 times the square root of 100 divided by 2. The square root of 100 is 10. So I'm going to have 10 divided by 2, square roots of 3. Well, 2 goes into 10 5 times, and I'm going to have 5 square roots of 3. Woohoo! There's my simplified radical form of the area of this triangle. Okay? Let's try something else. Let's try this one here. We got 300 x to the 18th. Well, 300, like we did that last one, that's the square root of 3 times the square root of 100 times the square root of x to the 18th power. Well, square root of 100, that's 10. So I'm going to say square root of 3 times 10 times 18th. I'm taking square root. You know what you do there? You divide by 2, and that becomes x to the 9th. So putting this together in the right order, it's 10 x to the 9th square roots of 3. That would be the simplest radical form. What is simplest radical form? It is where there are no perfect squares contained in the radical. I don't want to leave any perfect squares underneath the radical. Okay? I do not want to have radicals in the denominator of a fraction. So like this one up here, this fraction, I've got the square root of 64 divided by the square root of 81. Well, thank goodness 64 is a perfect square. That's going to be 8. And 81 is a perfect square. That's going to be a 9. And so I would say plus or minus 8 over 9. Okay? How about this other one over here? I've got the square root of 3 divided by the square root of 7. Well, neither one of them are perfect squares. But you know what? There's a trick. The trick is if I multiply the bottom by square root of 7 and the top times the square root of 7, because I got to keep it the same, that's just multiplying it by 1, then square root of 7 times square root of 7 becomes 7. And the 3 times 7 is 21. That's square root of 21. Fortunately, that can't be simplified any further, and that would be my simplest radical form. Okay? Let's try a couple of others. Looking at this one right here, 10 square roots of 6. 10 over the square root of 6. Well, I'm going to break it apart. Square root of 10 divided by the square root of 6. I'm going to multiply it times the square root of 6 over the square root of 6. Why am I doing that? That's multiplying it by 1. But what that's going to give me on the bottom is a 6. And on top, I'm going to have the square root of 60. Well, 60 is 5 times 12, or 4 times, let's see here, 20. 4 times, goes in there 1 time, 15. 4 times 15. Yeah, I think it is 4 times 15. That's equal to 4 times square root of 4 times the square root of 15 divided by 6. Well, square root of 4 is a 2. So I'm going to have a 2 square roots of 15 divided by 6. That goes into that 3 times, and I'll have the square root of 15 over 3. No radical in the denominator, no perfect squares left in the numerator. And the answer is going to be this one right here. Cool? Okay. This is called rationalizing square roots. Why do we call it rationalizing? Because if we don't do it, we're leaving that in the denominator down there. It really makes it difficult to deal with in some circumstances. So you got to know how to take care of it. Okay? So what we're going to do is we're going to make certain that when we're simplifying radicals and rationalizing radicals, we don't leave square roots in the denominator. Okay? So if I were dealing with this one, 18 over 50, well, taking a 2 out of both of them, that's a 9 over 25. That's 3 squared divided by 5 squared. That's 3/5. We got it out of there. Woohoo! Okay? If I had 1 over the square root of 2, I'd multiply it times square root of 2 over square root of 2 because I'm multiplying by 1. Sorry. And square root of 2 times square root of 2 is a 2, and that becomes square root of 2 over 2. On a calculator, if you do this on a calculator, just to show you that we're not trying to pull wool over anyone's eyes here, okay? 1 divided by second square root of 2, we get that little value right there. If I take second square root of 2 and divide it and move forward, divided by 2, I will get that same little fractional number right there. So I'm not doing anything that's changing the value of it. I'm just making certain it's easier for us to deal with later on, okay? So you're going to have to deal with this now and going forward, so you need to know how to do it. That's why we're teaching it to you. This one is finding the perimeter. Remember how we find the perimeter of a square? We have to add up all the sides, right? So I've got 7 square root of 5 plus 4 square root of 5 plus 7 square root of 5 and 4 square root of 5. Well, you know what? They all contain that square root of 5. I'm going to pull that out. Square root of 5 times 7 plus 4 plus 4 plus 7 plus 4. That's 22. That's 22 square roots of 5. The trick there was, because what's under the radical, what's under this square root sign here, is the same in every one of them, I factored it out and I could just add the coefficients together. What happens when they're not that way? Well, look at this one over here. We got square root of 5 plus the square root of 20 plus the square root of 50. Yuck. But you know what? This breaks down into 4 times 5, and this one breaks down into 5 times 10. So what am I going to have? I'm going to have the square root of 5 plus the square root of 4 times the square root of 5 plus the square root of 10 times the square root of 5. They all have a square root of 5 in them, so pull that out. Square root of 5 times 1 plus 2 plus square root of 10. Yuck. Okay, well, let's still combine these two together. That's 3. And so what do we wind up with? We wind up with 3 plus the square root of 10 times square root of 5. If you wanted to write it a different way, you could say the square root of 3 square roots of 5 plus the square root of 50. Either one of those would probably be acceptable forms. Okay? Let's move forward here a little bit. Here's another one that we're going to get a little chance to work with. We got square root of 27 and square root of 75. Oh my. Geez, I don't know what we can do here. We got to get them as the same thing underneath them, right? Let's see here. 75 divided by. Nope. 75 divided by. Yep, it does do that. Okay. This one, 27. 27 is 9 times 3. Right? 75. That's 25 times 3. We're adding those together, right? So we're going to add square root of 9 times the square root of 3 plus square root of 25 times the square root of 3. Okay, pull out that square root of 3. Square root of 3 times square root of 9, that's 3. Square root of 25, that's 5. And so 3 plus 5 is 8 square roots of 3. It'd be this answer right here. That would be simplest form. Okay? Area of a rectangle. Another one that we're doing. So we got 2 square roots of 6 times 4 plus square root of 6. Well, this looks familiar. Couldn't we just use the distributive property and multiply them together? Yeah, we can. So this becomes 8 square roots of 6. How did I get that? 2 times 4 is 8. 8 square roots of 6. Right? And then 2 times that is going to be 2 times, well, square root of 6 times square root of 6 is just 6. And so I'm going to get 12 plus 8 square roots of 6. That would be my final answer. Now, in case you didn't notice, a lot of these things, you've seen me in the very beginning putting the plus and minuses in there, but I'm not putting them in there now, right? Because it just confuses things and we would get lost in all that. Okay? We don't have to worry about those normally, but they do exist, and you just have to keep that in the back of your mind. Okay? So, what's the speed limit right here? It says 2x equals 360 divided by 4. Well, that's 80 is equal to 2x. So we divide by 2, x is equal to 40. So we know that the speed limit here is 40 miles an hour. Did I exceed that speed limit with you? Because what we did here, we used specific function values and simplified polynomial expressions, transformations, and solve equations, factor as necessary in problem situations. Wow, that says a whole lot of stuff. But you know what it actually meant? Radicals. That's what we were doing, was that little bit of radical stuff. So just to keep you on your toes, yes, Algebra 1 has an EOC. Yes, you're going to be taking it. It is on May 5th. Okay? You should have gotten information about where you're taking it. Be at the same place you take the English one probably. Okay? May 5th. Don't lose that date. That's the date you'll be taking it. I hope you're ready. I want to show you that they do have some problems that look like quadratics on the test. Okay? So looking at this one right here, we're going to multiply x times x and x times 6, and we're going to get x squared minus 6x equals 27. Oh, you know what? We could do this just like we did the ones the other day. X squared minus 6x minus 27 equals 0. Oh, I know what this is. we factor this, right? That's got to multiply to make negative 27 and add to make negative 6. Well, 27 is 9 times 3. If I say negative 9 times 3, I get a negative 6 when I add them together. That's got to be my answer. Woohoo! So it's going to be x minus 9 and x plus 3 equals 0. Well, if it equals 0, that means that x is equal to 9 or x is equal to negative 3. So where did we get that answer? It's right here. Woohoo! We got it. Now it says to use the quadratic formula, but they can't tell how you're doing it. I can tell you right now, we used a factoring approach and it works just as well right there. Okay, let's look at this one. We're asked to solve this equation for x. Okay, it's got to multiply to make a negative 112 and add to make a negative 9. Wow. I don't know if I can do that one. 112, that's not divisible by 3. How did I know that? I added the digits together. 1 plus 1 plus 2 didn't equal a factor of 3, so it's not divisible by 3. But I bet it's divisible by 4, so I divide by 4 and I get 28. Not enough. So 112 divided by 8 is going to be 14. 8 and 14 add together to give me a 5. Darn. Not good. How about 112 divided by, nope, not going to be 6, divided by 12? Not going to happen. 112 divided by 14 is 8. 14 and 8. You know what? Those don't add to 9. It only adds to 6. So 112 divided by 4 is 28. That's going to add to 24. That's not going to work either. Well, they're saying 16 and 7. Wait a second here. I can see that there. So 112 divided by 7 is 16. That's where, you know what? Looking at their answers helped me here, didn't it? I see the 7s and the 16s. I know that it's got to be a negative 16 times 7 is equal to negative 9 when it adds together. My factors: x minus 16, x plus 7 equals 0. So x is equal to a 16 or x is equal to a negative 7. And that would be this one right here. Sometimes looking at the answers helps you a little bit there in finding your factors. You see, I struggled with it a little bit, didn't I? I'm not going to deny I wasn't finding the answers until I looked over here at what they had. And I said, oh, that's got to be what it's going to be. That's some context clues that you're going to be able to use during the test to help you get the answers. Okay? Okay. Now, practice makes perfect. You're going to find a lot of helpful links out there in the weekly announcements, okay? Over the next couple of weeks. Use those things. Use the EOC practice test and that I'll be putting out in class in the document sharing. Okay? Do the things necessary to get ready for this test. You're getting to the point where we've done enough that you could do a lot of the questions on the test and get it right. I appreciate you listening to this recording. My secret word for today is going to be ion. That's my secret word for today. So if you're watching this recording, make certain you send me the fact that you watched the recording and the secret word is ion, and I will give you credit for having watched it. Thank you very much, and I'll talk to you next time.